morning. And Roland, if you're ready, I'm going to switch screens and make you presenter.
Okay, great.
All right, everyone, enjoy your webinar.
Morning, everybody. We're just going to get started here. I hope everybody had as much fun on their Labor Day as I did, driving all over the Southwest. Let's see here. Get going here for a minute. All right, let's talk about Spark. It's fairly new for most of us, including myself. It's like all the Apache projects that you work through. They become, some of them become, rock stars in the open source world, and others kind of wither on the vine. Which ones are going to be the most useful to people? I think Spark is starting to become that big thing, obviously. And I think a lot of people, particularly those who are interested in machine languages and machine learning and that avenue, are the ones who are most likely to benefit from it. So let's get started here. I'm Roland Gosling. I've been working with computer technology, at least professionally, since 1990, a lot longer than that actually, but not as a focus. So I joined Pragmatic Works in 2014. Been working with SQL Server since 6.0. I actually got a short-term gig working with 4.2, but as I remember, it's mostly command line. Lots of other platforms. I have too many to name here, but predominantly in the last 20 years, I've really focused a lot on SQL Server. I occasionally had Oracle or IBM's DB2 interrupt me along my way. A lot of the Unix platforms too, because I started out my career on the Unix side first. And so I got a lot of experience there, and everything is obviously quite different these days. So I've been with Hadoop about 4 years. Started with Cloudera's implementation of Hadoop. Great product. And I also went on to work with Hortonworks as well. And these days, of course, working with Microsoft Azure and HD Insight. And we'll kind of get into that in a minute. So one time I got to meet the actual Doug Cutting in the real Hadoop, and that was a great moment for me. That toy, I think, by the way, if you haven't seen it in person, I think was made by hand by someone and given to his family. I don't think it's something you could go buy at the time. I'm hearing that people are imitating it now, but when I held it and looked at it, I was surprised. It looked like my wife likes to sew and that sort of thing. So it seemed to me like it was something that someone made, and I thought that had a certain cool factor that someone would do that. Anyway, that's actually Doug's son's actual toy, Hadoop. So my first version of data really started on TV. Now my dad was a second-generation computer designer back in the 50s and 60s, so there was a certain reality that came with some of this, so I wasn't quite so dumb. But I did tend to see things through that sort of lens, that that everybody had data one day and it'll all be easy. And you get these ideas from like these weird old shows like this one. I talk about data banks, and you're thinking, what is a data bank? The best thing in Star Trek's world, you could actually talk to it, and it would do things. The computer was, completely voice activated. You could just ask questions, and it would naturally go figure out what you meant and have context and everything. Wasn't that cool? And the reason I bring that up is that Spark is beginning to deliver on some of these promises. It's starting to become the bits and pieces that we might use to make some of those pieces a reality. It's just, at least it's one more piece, we'll put it that way. I think it's got some pretty long legs. It seems to be showing up everywhere suddenly. So I'm going to talk a little bit about the history of Spark, the basic architecture, and obviously this is mostly focused on Microsoft Azure's HD Insight that it comes with Spark on the previews. I'm assuming that most folks know what that is. A lot of you probably have downloaded it or not downloaded it, but gone out to your portals and set that up and are just dying to get comfortable with it and see what you can do with it. One thing to note is that we're talking about, in my case, it's just a 2-node cluster. It's very limited, and we're going to actually go through the setup of it, but if it takes too long, we may just do, I did sort of a baking show sort of thing and went ahead and created one because it can take a little while to create. I noticed when I created it over the weekend, it was like, I'll say 20 or 30 minutes to create. So I didn't want to run into a problem during the demo, so I went ahead and created one, but we'll see. We'll go through the steps and maybe abandon it if we don't need it. So I did a little quick analysis on the current situation with committers. I'm assuming everybody is seeing this probably knows what a committer is. These are the folks who actually do the work for open source, right? So they're schools, large companies, just crazy technology people who don't have anything better to do with their lives, those kinds of folks. So they're actually sitting out there, improving the technology on this, adding to what we know about it, and adding new features. And right now, Spark is one of those really hot projects where it's getting a lot of attention and getting a lot of release. But you can see a handful of companies pretty much are doing most of the work. Databricks, for example, is one of the early companies out there. I think they've probably got the most committers. Cloudera is right there. UC Berkeley, of course, is ahead of Cloudera. Yahoo is probably in the league somewhere in Cloudera size. So these are the folks who are actually adding new features and coming up with some new ideas for Spark. Yep. So let's go back to the original Hadoop for a minute. What we learned over the last, 10 years is that what we're trying to build are take lots of inexpensive commodity servers, attach local storage to those, avoid SAN technologies for both speed and for expense reasons. Came up with a series of schedulers, the FAIR scheduler being one of those, and others since that time, to kind of manage the projects, manage the jobs on it. So that's kind of where we started from. And if we step into this, we start thinking about that a little bit, because a lot of where we're going to go for a little bit is going to be less about that, because it's going to be virtualized. It's going to be in a cloud infrastructure. But it's important to remember that because the way that the infrastructure or the internals of the various pieces are built, still think in those terms. This is probably one of the very first physical Hadoop clusters I ever built. Not much more than a couple of data nodes and a couple of name nodes. And in this case, I've included one as a client node. And that's really kind of typical of this, right? When we get out there and start working with it. But amazingly, with 7 data nodes in this configuration and using compression and all the rest of it, you're able to get something to the tune of 400 terabytes out of systems like this with just 7 data nodes and 2 name nodes. So we start to, when it gets really physical, we start using dedicated switches, things like that. But it's extremely fast, and it really is comparatively cheap. Revisit the stack for a second. The open source version, of course, has Umbari on top of it. And these are all the various pieces that we all talk about and think about when we're talking about Hadoop. And then if you really look at, that we've had these projects around now for some of these for quite a while now. A lot of times we'll also have somebody that's got an HBase cluster and basically running a pure HBase and probably not much else, since it tends to be a real resource hog. All right, so we got into Mapreduce, and when we got Mapreduce, we found out that it takes a lot to get those big gears turning. It takes a while to do anything. It's particularly any kind of filter statements, any of that sort of thing. It's going to take a little while to get all those gears spinning. When we get down to remembering that Mapreduce, where we're taking the input data one side, mapping it, doing splits on the data, sorting it, doing the merging, and doing the reduction, and then outputting the data. All of those things are things computers love to do, but it takes a lot to get those wheels to turn. Then we decided we'd go down the road of non-Mapreduce solutions, right? So how could we get at the data and avoid trying to go through the pains and arrows of dealing with Mapreduce and the speed problems that we'd see? And to that end, we got folks like Facebook came out with Corona fairly recently, I think. Cloudera's Impala has been around for quite a while. There have been some others too, and I was trying to think. I ran into at least 2 others, and I just can't think of what they are at the moment. But they bypass the whole Mapreduce framework and pretty much access the data. And you can kind of do some similar things, like we could just take some of the examples from Microsoft and actually talk straight into HDFS, or even talk into blob storage and pull that straight into Excel, provided it was organized in a way. And you could actually do that, not invoke Mapreduce. So anyway, Mapreduce in itself is not evil. It's just it is what it is. So what is Spark? It's really not more complicated than it's a top-level Apache open source project. And pretty often it's associated with Hadoop, because I think that some of the earliest implementations went hand in hand with Hadoop. Seemed to be sitting right on top of and taking advantage of HDFS. Not a big surprise there. The difference kind of is that it really is focused on being an in-memory sort of solution. And so when you do that, you're cutting out a lot of the noise, especially when it comes to disk access and things like that. So it contains, these native APIs for Python, Scala, and Java. And with a new release, we just had this, I think it was in July. Somebody correct me if I'm wrong there. But I think in July we started with 1.4, and that included R. So the other thing to know is that by its very nature, when they built this thing, they were thinking pipeline, right? Kind of the way we think when we're out in the command line world of, say, Unix, and piping together all kinds of crazy inputs to outputs to inputs, the way we like to do. It's that same kind of idea. So it comes from that sort of legacy. In 2007, Microsoft came out with this idea called Project Triad, and they wrote a whole white paper around it. Little like, if you remember your Hadoop history, you'll remember that Google's file table system started out just as a white paper, and Yahoo picked it up and started doing some exploring along with other people, and that became Hadoop. It was just kind of the similar sort of thing, where we had kind of this same sort of vision, just the big picture vision. And I always find it's interesting, that the other folks have gotten a lot of attention, but it was really interesting that Microsoft started this in their early days with Triad. So then here's kind of a timeline. Like 2007, Triad came out, and in 2009, the good folks at UC Berkeley started exploring that white paper and trying to implement that. 2010, it became open sourced. In 2013, it became a top-level Apache project, and now we're just released our 1.4 version. So what this is really about under the hood are what's called RDDs. These are resilient distributed data sets. Um, Basically, because it's across, a Hadoop cluster, in theory, it's going to have that sort of resiliency that we have to do a retry when we lose a server, some such thing, disk goes bad, whatnot. And so it comes down to transformation into actions that happen inside these RDDs. We'll kind of go through that here really quick. So then there's the notion of Rdv partitions, right? So if we kind of go from left to right on this chart, we have this driver application out there. I will say it's using one of the forms of the Spark system. Most often in this case, it's obviously going to talk to HDFS, and then go from that point. Those partitions are 1, 2, and 3 above are fed to the various data nodes to do the actual work. Over on the far right, we have sort of this logical partition, and that's kind of what Spark sees, this logic when it's all put together after all the end result. I'm kind of really simplifying a lot of this for time. There's a lot of good reading on this, and it's really deep. UC Berkeley's site is probably one of the more, I think it's one of the better areas. It's actually more readable than some of the other stuff. So I encourage you to go there. So we talked about the transformations a few minutes ago. We started talking about what they are. These are all the transformations available. Aggregate by key, Cartesian. Cartesian kind of works kind of like it does when we do a Cartesian join, we'll say in an RDBMS, coalesce. All of these are pretty common and should be very familiar to data folks for the most part. Some of them will be specific, but for the most part they're pretty understandable. We all know what joins are, intersections, filters. All of those should be little keywords that would give you a vision of what we're talking about here. So those are the transformations, and here are the actions. Collect. Well, that's usually the way, kind of the last step in the whole process when you call after it's done a lot of transformations, is collect. We'll be preparing it for output. And again, for each, we all know what a for each loop looks like, I would think. And the reduction. Take is kind of like our top statement in SQL Server, in T-SQL I should say. And you could do a take order, take sample. So these are all just some of the RDD actions that you can do. They're all well documented. I'm not going to spend a lot of time in this area. One, I don't know it as well. I'm learning it like most people. I haven't used them all. So, but know that they're out there. They're well documented on the Apache side. They're easy to find. And I've got some links in the back. So I mentioned the current release is 1.4. That includes in our library. So the folks that are just itching to get to we're finally getting the tools. There's kind of an upside and a downside. I'll get in a minute on that topic when it comes to HD Insight. So what is included in the 1.4 release of Spark, and I'm talking about the Apache release, includes the ROI library. It includes a machine learning pipeline. Python's API is now closer to Scala and Java's APIs. And the kind of project goal seems to be to get all those APIs, whether it's the R area or Python or Scala or Java, to all have similar features, have a similar feature set. And I think that's what they're driving toward. And that's going to be talked about in a second. But it was also a broad re-architecture of a lot of the Spark internals for performance reasons. So it is a big deal. As supposedly, I haven't worked with 1.4 yet, but supposedly the 1.4 release is really fast, much improved. I'm about to find out. Um, so the main features, Spark contains these basic 4 things. We have Spark SQL, Spark Streaming, Spark ML APIs, and ad hoc analytics. And the way it kind of lays out is this. We've got these APIs that are capable of sitting on top of the Spark core, and Spark core can leverage Yarn, HDFS, and all like we mentioned. So really not anything you probably haven't seen before. I think, for me as a data guy, one of the coolest things is that there's so many ways to get data in and out of this thing. It just almost begs to be an ETL solution because it is able to consume and read and write all this stuff without a lot of sweat. And that's getting more and more important, particularly with JSON becoming, just another kind of similar topic of similar size and consequence. Personally, I've used sequence files a ton, and they are so fast on Hadoop, but I can't imagine life without those things. And so that's another interesting piece too. Works great with Hive. You have Spark on Hive, which we're going to explore a little bit. Probably one of the few demos I do today. We're going to go out and play. Just drive it around to give you some sense of what exactly we're getting out there. Can work with Jdbc. Not a big shock there, since almost everything in that world is Java-based. Can work with HBase and Cassandra. I have worked with Cassandra in the past a little bit, and also HBase, but not to any real degree. So here we kind of start to get, this is borrowed from a lot of the Apache documentation on this very topic, where we have, you'll notice here we have the metastore here. Trying to get my, see if that'll work. Nope. Back. The metastore on the left of this lower graphic. Obviously, we're probably thinking of Hive, and we're thinking of HiveQL, UDFs, and SerDes. The metastore is a really important piece. Who wants to describe that data more than once? Or worse yet, do without the description and just go after it physically. Once you've described the data, that's just awesome, not having to do it again. And so we find lots of uses for that data, whether it's being fed into HCAT, and HCAT feeding it into things like HBase, for example, or PIG. Sometimes those paths can get really, really long, and having that metadata store out there means you don't have to type all that stuff. Awesome stuff. Then we talk about, over on the right-hand side, the BI tools, Jdbc, ODBC, and Spark SQL. These are all the things that we can do with this. Just as a side note, Spark used to have a little side project called Shark, and now it's Spark SQL. So you may run into references about that when you're out digging around on the internet or talking to other people. And that's all that's about. If you look in the upper right-hand corner, you see an example from the Apache site. Basically context is everything with this stuff. And so, what the author intended was to declare a context, which is that Hive context SC, and then the results to contain the results of the query and come back. We'll do something similar when we go out in our HD Insight land here in a few minutes. So the streaming side of this, being able to read directly from HDFS, Kafka, Flume, and Twitter, doing sentiment analysis. I think I've seen, I don't know how many examples of people doing that, which is awesome. That's a great thing to do. But if you haven't worked with things like Flume, it can be a little elusive because, Flume is a great way to automatically move log files in, which is why it was named that to begin with. They were moving lots of log files, and of course, if you get around logging like the actual trees, we think of flumes being the way that water can move the logs into a storage area or further downriver or whatever. It's very interesting, but in any event, it's all fault tolerant because it's all based on Hadoop. Machine Learning Live, ML Live, I should say, can use any data source in Hadoop. Not a real expert in this area myself. I'm working on that like probably most of you. But R is at the top of my list. I'm starting to take some of the online courses with Stanford and with Berkeley. There's some good ones out there for free, so by all means take advantage of that. So these are just some of the, well, I guess these are most of the actual built-in library methods you can call and what they can do. Now, a lot of people I know, maybe I was one of them, slept through statistics class in college, but these, if you love statistics, this is your place. This is where you go. So things like linear regression or single value decomposition, those pieces are already done for you, and there's lots of great examples of how to use these. So kudos to you if you love that. GraphX is the last kind of section. We got page rank being one of the first sort of methods, named after page. Got connected components, label propagation, all of that, basically on how to create a graph. And here's some of the example code that was actually written in Scala. There are tons of Scala examples as well. I'm not a real fan of that language. I just haven't adapted to it as easily as I thought I might have. I'm kind of headed towards the R side more for the data reduction and less about this area. So Project Tungsten's coming out, and it actually is out, I guess you could say. Part of the Project Tungsten is to deliver some of this features that were delivered in 1.4. Where they're taking off some of the heap management from Java, trying to do that more directly. Be kind of interesting to see how that plays, because Java is just so intertwined in all of this stuff. But I'm sure that there's a will, there's a way. Let's see. So some interesting notes about this. These are the versions that you're limited to within the current preview versions, right? They're easy to stand up, and you can just go look, and we're going to do that here in a few minutes. So we're nowhere near the current release, but that's not really surprising. It takes a little bit of time to suss out whether a release is worth installing. Is it a good thing, bad thing kind of decision? I'm sure Microsoft is going through that now. However, that shouldn't stop you. If you really want to stand up a Hadoop cluster running, whether you did it as just as virtuals and run Hortonworks or Cloudera or something out on Azure, you could hand install the latest edition of Spark on that if you chose to, and I think you can actually do it with HDInsight. I haven't done it myself, but I believe that's a doable thing too. So either way, it's going to involve some trial and error and pain on your part. But for the most part, I haven't had a lot of trouble with the small things I've asked of even the 1.02 version that we have out there. So everybody kind of gets down this choice here, PowerShell or Web UI. And I thought about this over the weekend, and I was thinking, I think I would probably enjoy just using the Web UI in this case. But you could do this in PowerShell pretty easily, and there's a lot of good blogs on that. I know there are very specific steps to doing this if you decide to go off-road yourself, no pun intended, and add the bits for Spark yourself. You could, and it's well documented. So I do think that should help you quite a bit. So let's take a second. I'm going to slip over here. I've got my current Spark cluster running. It's like any big company, we've got like probably 10,000 things out here by all our good folks that work here. We have our One Insight cluster. I don't feel like the new portal yet because I think you still have to use the old one for some reasons. So if we go here, we can actually click on this cluster. Exciting, huh? One of the parts that that you're going to probably find out if you haven't already is you're going to end up having to connect using RDP to actually do a lot of the work. And I think it's kind of a little bit of a drawback, at least from my perspective, because you're now going to have this one connection, and you can only get one. You can't have two or three to these, at least as far as I know. So that means you're going to have to share a pretty important credential with someone who probably is going to be a developer. So I don't think that's a big problem in the bigger scheme of things. The way Microsoft has done this kind of gives us a chance to stand up a cluster, load it with data, do some work, and tear it down. As one of the gotchas of HD Insight is you can't really stop the cluster. Not like you can in any other traditional, Hadoop environment where you can start and stop, nodes, or you can start and stop the entire cluster. Here you can pretty much turn it down. I think you can turn on and off the Hadoop services, but I don't recall some of the issues with that. But let's go back out here. Let's try to connect to our own cluster here. Yank out some of this trash I put out here. Right. Oh. Grabbed the wrong thing. Yay. If we have time, I'm going to go back through and we're going to create it by hand, at least through the portal. Not probably with PowerShell today, but we'll do it at least through the portal. I added this one for Spark Shell. When you come in, you basically, everything except for that is what Microsoft sets up for you. So all of these are kind of useful, right? So you're going to get to see the name node status, and you click on it. It'll tell you the current status of the cluster. Now, this is just a 2-node cluster. It's not really had a lot run against it. So, but in any event, service availability. Checking along. Not all that impressive, especially since it's an unknown host. Not sure why. Darn status. That looks familiar. Make this a little bigger so maybe you can see it. A couple of different jobs have run on this. Probably things I ran. This is actually the Spark UI. Now I think last time I installed Spark on a physical cluster, it's like expecting by default to run on 4040. You'll notice up here it's running on 8080. So if by any reason you get off the beaten path there, you can see that it's not on the port you might expect it to be on, and I'm not sure why. So these are the two worker nodes, application IDs that are running, and completed application. So let's say, click on this. Loading guild. All right. Let go of that. Now over here, I always like to make these little shortcuts on the desktop. So what I'm doing, just so you know, like I can make them for Pig or for Hive or anything else, is that I'll go ahead and make this little shortcut. You'll notice that the apps area, we'll get in that area real quick. Come on. All right, hang on. Doesn't seem to want to open. If we go to see apps, everything is down this distribution area. So you can start to see what's in here. So this is mainly for the people who've never done this before. So you can get some idea of what's out here. Scoop is here, Jdbc is here, some Spark add-ons, I'm not sure what that is. Good old Pig. And Piggyback too is out there, I'm pretty sure. Somewhere in here. Probably in live. Yep, Piggyback jar. Fabulous open source deal where people have written all kinds of functions that you can use in Pig. Save you a lot of time and effort and expense and hassle. Tez is on here as well. So there's a lot to choose from in here. HBase, I've not tried HBase on this. I'm not sure I would because it's a real pig. No pun intended. But no, it's here. Here's Hive. And if I wanted to go into Hive, I'd go into the bind directory. I'd find the Hive command file that they created and simply run it. Should start here in a second. I can learn to type now in front of all my friends here. So there's only one table in there. It's probably in the default database. And there is just one. So let's just first kind of give you some comparison. So now I just ran a little Hive query, right? You've probably seen a few times of this. I didn't create that table, so I don't know what the shape of it is. So let's just see device make, select star from. Now, Mapreduce is going to kick in, and it didn't find any. It should have kicked in. Say Samsung. Oh, it's bigger than that, isn't it? Yeah. Probably Android. Nope. Any event, I can't suss out which of the columns. I'll see. English, US. All right, let's just do this. Nope, there's quite a bit of data out there. All right, it's not too bad for two little virtual servers. Moving along pretty good. I think it's got a total of 4 cores. All right. So let's get back to the original premise here. I have some I'm going to go run the Spark shell. Kill it here in a minute. We're going to start up the Spark shell. I could have done that like that from the command line. It takes a few minutes to get this stuff working. Now, you'll get the Scala prompt when you finally have gotten to the point where it will actually do anything. SQL context, here we go. All right. I love that little graphic, that's just perfect. Used to see those on bulletin boards and stuff everywhere. All right, let's get some of these examples working. One of the things about Spark is it has this notion of laziness where it won't do anything right away until it has to do something. So you notice it set up a partition, right? RDD1 that contains RDD1, but it didn't do anything yet. It just did that part of it. So now we're going to go get the counts. Again, it still hasn't done anything. It's just sort of lazy stuff. Don't do anything until you have to, I guess. That's the theory. Now it's going to have to do something because I've just asked it to go give me the count from an array and then print the lines. That's busy. But see how fast that was. I was, most of the time if I'd done that same query in Mapreduce, let's see what we pull back here. Okay, look over here. Give me a second here. By split. Gee. Oh, that's because I don't have it. So that's actually running that in Scala. Here's we're actually running it as a Spark context, as a Hive context, rather. So we can go by like here. That's what I was thinking. Once again, context. There it is. So basically, it can take almost any source, whether it's HDFS like the first example, or whether it's actually pulling it from Hive. When it has to come up through Hive, it's got to go through a few extra steps to get at the data. And Hive itself, for the most part, isn't blindingly fast, but I'm actually always surprised how earlier when I was playing with this, how fast this little 2-node cluster has been. All right, so let's stop that for a few minutes and go back to our presentation here. So, like I mentioned earlier, one of the things that I see as a tech guy, and especially a data guy, is I'm a little bit always put off when people can change the behavior of something like a cluster. Now, one of the things that I've seen is, or read that is important is like there's a cluster out there in China that's like 8,000 nodes running Spark. I think it's the biggest one. It's some kind of a social networking site that like 1 billion people belong to, literally. Um, and so, ask yourself, is this a good idea to have people out there having that ability? So what I'm asking you to do is think about what the implication would be. Perhaps what you don't want to do if you have a working Hadoop cluster, probably what you don't want to do is install Spark on that cluster. What you probably want is a limited cluster in Azure where people can do this kind of analysis. This kind of idea behind HD Insight of stand it up, populate with data, do the analysis, tear it down, is actually a great place for this. So anyway, so I'd be a little bit of word of caution. Uh, they can actually literally change the configuration from the command line and say, you know what, I want each of these queries across the nodes, using RDDs, it's going to have, a gigabyte of RAM instead of, I think the default's like 100 or something. So you don't want to just trust anybody with that. Just be careful. It's all a balance, and kind of that point, I remember times that myself, I've installed like HBase on the same cluster and watched everything failing and having trouble keeping up because it's just a pig. So it's probably that same thing. Find a balance in what you're going to do. Having more than one cluster a lot of times is a good way to separate out the different ambitions that people have with this. So if you have one for general data lake sort of storage, you have another Hadoop cluster that maybe just is handling Spark. You have another one that may be handling HBase. And so you don't end up having this mix of things. So the balance is a really important thing to find on this. There are quite a few resources on this. I'm sure every one of you has seen most of this kind of material. If you haven't, these are some of my favorites. Go straight to the AMP lab at UC Berkeley, for example. There's some great presentations also on Stanford's website. They've got quite a few. Of course, good old Apache is always there for everybody. Have been forever. And there's quite a bit of documentation around installing and configuring HD Insight, particularly with the new Spark piece, is gotten to be around. So let's, well, we have a few minutes. I'm going to go see if we can stand up a cluster manually for you. So give me just a second. Let's see. So here you go basically into Spark. And I always give it like HTTP when I'm dealing with Hadoop. And then in this case, it's Spark 2 or something. Specifically, if you're just playing with stuff, you don't want to cost your company a lot of money or yourself. I always dial this back a little bit. Let's see. I'm going to go after my own storage account too. Let's also have some really specific requirements when it comes to passwords. Because I'm tearing this down, I don't care that you see it, but I know it has to have one from each category: capital letter, lowercase letter, number, and a unique one of the characters, non-printable character, or maybe extended characters, like that. And I think it's like 10 characters long too, so you probably all seen that, but in case you haven't. That's an admin, HTTP user admin. There we go. Go next. That's pretty much it. I think we can check back here in a few minutes to see how it's going along. As you can see, it's changing a little bit now, and trying to run. But if it's anything like yesterday, it could take a little while. So we'll check back in a little bit. I see I've got some kind of message down below. Oh, it's a preview feature. Yeah, we know. That is actually important to remember that it is still in preview. So you probably want to go slowly, a little bit cautiously. All right, we're a little bit ahead of schedule. Liz, do you have any questions out there from anybody?
We actually don't have any questions in the queue, so you must have done a very good job of covering the topic.
Everybody's asleep out there.
I'm alert.
All right.
Okay. Well, if that's the end of the session, thank you everyone for joining us, and thank you so much, Roland, for taking the time to present to us.
Thank you, bud. Thank you, everybody.
Have a great day, everyone.
You too.
Bye.
Bye.